welcome back. Or if it's your first time watching, welcome. In this video, I want to cover a different kind of truth table. So by now, you've probably used truth tables to test for validity a number of times, and truth tables are great tools for testing for validity. They're very effective. Standard truth tables test for validity basically using brute force. You start off by writing all of the possible combinations of truth values for the atomic statements. Then you go ahead and you calculate all of the possible truth values for all of the compound statements. And this, of course, leaves you with all of the possible combinations of truth values for the premises and the conclusion of a given argument. The problem is that this can get seriously tedious. For every atomic statement you add, the table requires twice as many rows to fill out. So this is where it's useful to know how to construct abbreviated truth tables. In this video, I'm going to teach you the structure of abbreviated truth tables, everything that you need to know in order to build them yourself, and then we'll work through some simple examples. In the future, I'll upload some practice videos so that we can work through some tougher problems together. And those videos tend to be unscripted, so we can actually see what it's like to get through an abbreviated truth table. All right, so let's start with the structure. Abbreviated truth tables are typically much shorter than standard traditional truth tables, oftentimes requiring just one row. The cost of this is that they require a little more thought on your part. This is because rather than just churning out all of the possible truth values and then trying to identify a row that meets what you're looking for, right, all true premises and a false conclusion, when it comes to abbreviated truth tables, you're tasked with actually trying to build the one row that you're looking for. This means that you'll actually be assigning truth values to atomic statements rather than just trying to identify a row on a given truth table. I'll say more about that in a minute. Abbreviated truth tables are built just like standard truth tables, with the exception being that you start off by just making enough room for a single row. And this is because we will need only one row most of the time, though there are exceptions. It is still possible to need 2 or 3 or 5 or 8, but that's pretty rare, especially if you follow the instructions that I'm going to give you. Before you can actually build abbreviated truth tables, there's some stuff you need to know first. But don't worry, the stuff that I'm going to tell you, I'll also repeat as we work through the examples. Perhaps most importantly, you need to have mastered the logical connectives. That is, you need to know how to evaluate all of the logical connectives by heart. When you're building a truth table, you're actually going to be choosing which values to assign to the atomic statements, as opposed to just listing out all of the possibilities. And if you haven't mastered the logical connectives, then you won't really know which truth values to assign to which statements. So that's the most important thing you need to have in mind. In addition to that, I have a couple of guiding principles that will make your life much easier. The first I call the no choice principle. And this principle says that when possible, you should assign truth values only when you are forced to do so. And you'll see what that means in a minute. And the second principle I call the conservation principle, which just says that when you can't make a forced choice, when the truth table does not require you to assign a particular truth value, then you should make the fewest truth value assignments that you can, right? So try to assign the fewest number of truth values possible. By the way, I named these principles, so if you bring them up to your professors, they might have no idea what you're talking about. Okay, now we have everything that we need to work through some examples. So remember that we're using these to test arguments for validity. In a standard truth table, we go ahead, we write out the possibilities, and then we identify a row that has all true premises and a false conclusion. Find the row, argument is invalid. Can't find the row, argument is valid. Abbreviated truth tables are different. Our objective here is to create the row that has all true premises and a false conclusion. If we can do that successfully, then we know that the argument is not valid. If that turns out to be impossible, then we know that the argument is valid. To achieve this, we always want to start by making the conclusion of the argument false. That's the first step. Then we can move on to try to make the premises true. Okay, let's begin. So here's our first example. Notice that I created only one row because it's all we're really going to need. Now, like I just said, we're going to want to start by making the conclusion false. In this case, our conclusion is P. Well, there's only one way to make this conclusion false, and that's by making P itself false. So we'll assign false to P, and that gives us a false conclusion. Okay, so now that the conclusion is false, we can go ahead and move on to the premises. Our objective now is to make all of these premises true. Remember that the principle of no choice asks that we assign truth values only when absolutely necessary. Lucky for us, for this first example, every single move that we make is going to end up being a forced choice. The first premise has P as its antecedent. This is where it's important to have mastered all of the logical connectives. Any conditional that has a false antecedent is going to automatically be true. It won't matter whether the consequent is true or false. Either way, the conditional evaluates to true. Automatically, the first premise turns out to be true, and we didn't have to assign any values to R or to S. Notice, you could have assigned truth values to R and to S if you had wanted to. It wouldn't have changed the truth value of the first premise. But the thing is, doing so won't help you, and it might hurt you later on down the line, since this means that you'll have less flexibility when it comes to your other premises. All right, now let's move on to the second premise. In this case, we have a conjunction, and we know that conjunctions are true if and only if both of the conjuncts are true. Otherwise, they turn out to be false. So, in this case, we have no choice but to assign truth to both R and to S. And notice, since we hadn't assigned anything to them earlier, we have the flexibility to fill them in now with the truth values that we need. We were successful in making all of the premises true and the conclusion false, and so we know that this argument is invalid. We didn't have to guess at any point. Every truth value assignment that we made was forced, and so we could be confident that we've correctly evaluated this argument. All right, let's move on. Here is another example. Now, as before, we have to begin by making the conclusion false. There is only one way for disjunctions to be false, and that is for both of the disjuncts to be false. This means that we have no choice but to make C and D each false, and that will give us a false conclusion. Again, this was a forced assignment. There is only one way to make the conclusion false, and we absolutely need the conclusion to be false in order to test this argument for validity. Now, following our principles, let's go ahead and assign truth values so that our premises all turn out to be true. Notice that you shouldn't start with the first premise. This is because there are 3 ways of making it true. It is, after all, a disjunction, and disjunctions are true when either of the disjuncts is true or both. If we went ahead and we made them both true, this would be a violation of our conservation principle, which asks us to make the smallest number of truth value assignments that we can. And there'd be no point in assigning truth values to both of the disjuncts to make a disjunction true when just one would suffice. But even if we went ahead and just wanted to make one of them true, we haven't worked through any other premises, so we don't know which one we should make true, which would make this a guess. The no choice principle tells us that we should avoid guessing. We should make truth value assignments only when we are forced to, right? Unless that turns out to be impossible. Making a truth value assignment now might just hurt us down the line, so it's best to leave premise 1 alone. Let's start by looking at the other premises. Taking a look at the second premise, we can see that it's already true. There's no need to make any other truth value assignments since C is already false, and any conditional with a false antecedent will just evaluate to true. The same holds for the third premise, since D is already false. So this premise is also true, and we haven't had to make any other truth value assignments. And so we're back to the first premise. We need this premise to be true, and there's more than one way to do that. There's no forced choice here. We can make this true by either making A true or making B true. The conservation principle asks that we not make them both true because it's not necessary. And since there's no forced choice, we can just go ahead and pick whichever we like. So I'll just go ahead and make A true. And so this argument is invalid. Okay, so in this particular case, we could have just gone ahead at the very beginning and made both A and B true in violation of our principles, and it wouldn't have made a difference to the evaluation of this argument. However, it's best to avoid doing that. Although in this particular case it wouldn't have hurt us, that won't always be true, and we won't always know. So just follow the principles. It's the easiest way to avoid making mistakes. All right, now let's work through this argument. As always, we start with the conclusion. We have a disjunction, and so we need to make both disjuncts false in order to make this false. As before, we need to go wherever it is that the truth table will force us to make some truth value assignments. So let's look at the second premise. Since C is false, we have no choice but to make A false too. Our objective is to make all of the premises true. We can't make A true since that would make this conditional false, since it would have a true antecedent and a false consequent. The only way to make this conditional true, given that its consequent C is false, is to make the antecedent false too. Notice that the same goes for the third premise. Since D is false, we have no choice but to also make B false. It's the only way to get a true conditional. So up to this point, we've followed our principles and all of our choices have been forced. The only way to make the conclusion false is to make both C and D false. And the only way to make the conditionals of the second and third premise true is to make the antecedents false. And so all that's left now is to try to make the first premise true. But we can't. All of our atomic statements at this point have been assigned truth values, and all of those truth value assignments have been forced from us. And so the first premise is, by necessity, false. That means that it is impossible to make all of the premises of this argument true while its conclusion is false. So the argument is valid. All right, let's work through one last example. I want to work through this example because if you've followed everything I've taught you so far, you may still end up with more than one row in evaluating this argument. This isn't a bad thing. It's okay to end up with more than one row, even if you could have avoided it. It doesn't mean that you wrote a bad truth table. Sometimes it just happens that way. So let's work through this thing. We have to begin by making the conclusion false. But, as you might notice, the conclusion is a conjunction. There are 3 ways of making the conclusion come out false. Now, the conservation principle tells us to assign the fewest number of truth values possible, but that still leaves us with 2 possibilities. And looking at this argument, it isn't immediately obvious whether we should start by making E false or by making P false. So it looks like we're just going to have to guess. That happens sometimes. Okay, so we'll start off by making E false, and this will make the conclusion false too. Now let's look at the first premise. The first premise has a false consequent, which means that the only way to make this conditional turn out to be true is to make the antecedent also false. So we'll go ahead and make N false. Okay, so far so good. But now look at the second premise. Since we made N false, this conjunction will also be false. And so we end up with a false premise. But this does not prove that the argument is valid. Remember, there's more than one way to get the conclusion of this argument to turn out false. So we aren't done. We have to consider the other possibility. This means we're going to need another row. This time around, let's begin by making P false instead. This will also give us a false conclusion. And this time, we haven't assigned anything to E. Going back to premise 2, we're going to need both of these conjuncts to be true if we're going to have this premise be true. So we'll have no choice but to make Q false so that its negation, not Q, turns out to be true. And we're also going to have to make N true so that the entire conjunction evaluates to true. Now let's go back to the first premise, which this time we can also make true. Since we were forced to make N true, that means that we're also going to have to make E true so that the entire conditional turns out to be true. All right, we're in good shape. We've managed to make the first 2 premises true and the conclusion is false. Now we need to look at the third premise. And it looks like there's nothing for us to do here. P is already false, and any conditional with a false antecedent is going to turn out to be true. It doesn't really matter what Q is. And so we've shown that this argument is invalid. All right, one last thing about this final example. There is one more principle that I want to give you that, had we followed it, would have made us have to write just one row for the last argument. This final principle isn't as important as the other 2. Also, it'll take a little bit of practice in order to adequately follow it. I call this the foresight principle. And it just says this: before assigning any truth value, make sure that you look at the rest of the argument to see what its impact is likely to be. This principle requires a little more practice to execute reliably. So, in the last argument, when we were deciding whether we should make E false or P false, we could have settled the issue by looking at the other premises to see what the impact of each truth value assignment might be. Specifically, we could have looked at premises 1 and 2. Making E false would require making N false in order to make the first premise true. But that automatically makes the second premise false, since now we have N, which is false, as one of the conjuncts. Seeing that would, right off the bat, allow us to settle that we should make P false and leave E alone. But like I said, having this kind of foresight takes practice. It's not the kind of thing that you're just going to be able to do right off the bat, especially if you've only just started to construct abbreviated truth tables. All right, if you practice everything that I've taught you, then you should be a master in no time. If you'd like to see more videos about logic or philosophy more general, you should consider subscribing. Thanks for watching. Bye.